Hi everybody, it is Riccardo Zamana from Italy. It's a pleasure to be here, and today we will talk about ADX, Azure Data Explorer. I'll make a complete overview of the service, suggesting some tip and trick in order to be productive in few hours. My special thanks go to all the sponsors listed here, who are the first protagonists of this world event. My opinion is that this event is destined quickly to enter everyone's earth. This is the agenda, and today we will talk about ADX from many points of view in order to discuss which are the benefits of this service, which are the capabilities, in some kind of limit that we can find in our daily work. But I would like to talk to you about the overall envision of the entire service, which is destined, in my opinion, to be one of the most used in the world. Okay, let's go with the first topic, that is ADX basics. What is ADX exactly? ADX is a fully managed big data analytics service based on an analytical database. Analytical databases are optimized to query and run advanced analytics on large volumes of data with extremely low response times. Modern analytical databases are generally distributed, scalable, and fault-tolerant. They are columnar-based databases that deal with the compressed formats and with an intelligent software infrastructure composed by a blend of in-memory and disk caching technologies. This, for example, is a multi-temperature data processing path schema. Probably you know about it with the term three-way lambda architecture, in which you can find hot path, warm path, and cold path. Hot is in terms of instant results from a continuous data flow. Warm path means analytical approach, so not immediate, but full of rough data to be modeled by a process engineer who thinks about a problem or with the goal of finding a better point of view in the data in order to discover anomalies or trends or something like that. The cold path doesn't mean unreachable. Okay, so cold path stands for hour freshness, year retention, but reachable data. So the question is, in a multi-temperature situation, is there any Azure service that can be the answer of all the three data paths? The response is yes. There is only one software that is the answer to all the three data paths. And this is what I mean with the term ADX, okay? Look at this schema. This schema says four important things. One, which is the context of ADX. The context is the mix of many sources that comes from IoT, from a data lake, a generic data lake, from on-premise services and servers, okay, and from other cloud platforms. So you can see it as a sort of timeline-based, okay, bucket of data that comes from many places, and you can have so many connectors that are linked to ADX. For example, Data Factory, APIs, Logstash plugins, on-premises Kafka sinks, okay? Or pure cloud services such as IoT Hub, Azure Storage, or Event Hub, okay? So many places, many contexts, many sources, many plugins, one unique infrastructure that is composed by many layers. So you can have stream ingestion, batch ingestion, but all the data management is one unique data management platform, okay, with several storage levels. For example, you can have a cache-specific storage level composed by many SSD disks that are used to contain fresh data. After the cache period, all the data is moved to another storage level that is composed by many disks in arrays. Okay, and all this kind of data movement is transparent to you. On top of that, you can have several ways to query and visualize all your data. And you can, for example, export your data to other services. For example, Azure Synapse or Azure Data Lake. But from the query and visualization point of view, you can have many front ends. You can have a native UX that is delivered on top of ADX, or you can use it with Power BI or other tools externals to Azure, for example, Grafana. Or you can integrate all the data and the Kusto query engine with other applications simply with Logic Apps, for example. So it is a very complicated service, but is a very complete service that brings all the data, transform the data, query the data, and visualize the data, or orchestrate the data to other services. Now, I want to talk what is ADX for me today. I work with ADX from more or less 1 year in production. My work is regarding industrial IoT and is regarding telemetry, okay, from machines. And ADX for me represents a valid alternative to many other on-premises services that I already have. For example, the first one is telemetry data search engine. So you can have a sort of Logstash, Kibana, and Elasticsearch replacement. Totally on cloud, totally managed on Azure. From another point of view, ADX is a sort of big TSDB cluster, and so is a wonderful service in order to manage all the warm path in order to generate the cold storage. And so it is a sort of replacement of MinIO and Kafka, for example. So sort of a mix of storage and append-only log. Third, you can use it as a sort of temporary database in order to manipulate the data and materialize the final data, for example, for machine learning operations, in order to materialize the data into other services. So you can materialize the data to Data Lake, Azure Data Lake Storage, or to SQL database. But my preference is to use it in order to monitor all your software telemetry, because with very few lines of code and some logic up, you can summarize information and send notification to everybody, okay, using a very, very huge amount of data in order to find out anomalies. And find the art of finding anomalies in logs is an art for me, okay? And only few people can do that. So you can bring all this kind of intelligence, put in some line of Kusto QL queries, and automate immediately. So which is the real role of ADX? The role of ADX is to solve problems through three key users. The first is IoT developers. So all the things about rule engine for insights or data checking and so on. The second role is the role of data engineer, so data comparison. And data scientist is the third key user for example, data exploration. There are other users, for example, system engineer, if you use ADX to find anomalies in your network or in your software. So you can bring raw data, refine data, derived other information, so the famous insights, spin up actions, okay, from KQL queries, and you can have fast KPIs and put all the results into a data warehouse. How is ADX is organized? Well, you have a sort of classical organization of entities. So you have the instance level. So what you pay is an instance of ADX, in which you can create many databases. Each database can have separated URL for ingestion, stream ingestion, and querying URL. Every database can be configured with different cache storage levels and retentions, and every database can be associated with different blob storage location. Sources. Data sources are different for every database you create. So you can have storage-based source. Imagine that you have a sort of Azure storage that is filled with the files, and the action of creating a file into that storage is triggered by a sort of event grid action, and transmit the action to Event Hub, and the Event Hub is used to ingest data. Or you can have classical streaming ingestion using IoT Hub, for example. You can have external destinations of data, Azure Data Lake Store, or Azure SQL DB, for example. And you can have external data retrievals, for example, Logic App, Power BI, and so on. Which is the data flow? Ingestion can be made with several connections. Azure Data Explorer has a rich connector ecosystem for batch and near real-time ingestion. And with the Microsoft first-party services, as well as open source distributed systems. So from Logstash, from Kafka, from several things, okay? You can use SDKs in order to build up your application, in order to be ingested with your own data flow. but overall you can have um, zero effort integration with many Azure services. So ADF, Data Factory, IoT Hub, and Event Hub. You can have, from the ingestion format perspective, okay, Azure Data Explorer supports a number of formats from CSV and JSON to binary formats like Avro, Parquet, or ORC, and it supports multiple compression codecs, okay? You can have many SDKs, and you can have tools, dedicated tools to rapidly ingest files, for example. So from the portal, ADX has got a dedicated UX, okay? And from the CLI, the CLI, and so you can use Light Ingest as a sort of batch tool to ingest files. We have two types of ingestion. Streaming ingestion, useful for alerts or triggers that comes from on-premises, and it completes the operations in under 10 seconds, okay? And the other method is batch ingestion, so you can upload files to storage or synchronize on-premises location with Azure storage, and then the miracle starts. So every 5 minutes or every 500 items or every 1 GB of data, it ingests a file. There are other techniques. You can use SDKs, for example, and or you can use for temporary exploration the inline ingestion. One of the most used tools to ingest rapidly is Lightingest, and you can find information about Lightingest download using this reference. Imagine that you can have to download a NuGet package, okay? Unzip the file, and inside the NuGet package, you can find the utility. It is a command line utility, okay? And this is an example. You can copy it and use it, changing the account name of the storage. That is, for example, the source path, but you can use your local path in order to transfer the data um, to a particular database, to a particular table in a particular instance. Which is these options? This is a fundamental options when you deal with some kind of file. And this is the mapping. So the relation between the fields that are inside the file and the columns that are in the database schema. Let me suggest one simple thing. My suggestion is pay attention to the ingestion time, because in every real situation, you can have delays from the field. And so it is important to understand the meaning of a particular argument in your light ingest command, okay? The creation time pattern argument. It is very useful to assign correctly the partition, because when you ingest data, all the data is indexed, right? But how is partitioned? And is partitioned by ingestion time. So if you deal with delays that are coming from the field, you have to say clearly which is the ingestion time. So the creation time pattern allows user to partition the data by creation time and not by ingestion time. Okay? So it avoids the delay and avoids the writing operation in the wrong partition. My final suggestion is use, check your data, create and destroy tons of tables because you are exploring data. So you don't know exactly which is the data, which is the right morphology of the data, okay, in order to be queried in efficiently, okay? So try many times, try many formats, consider Parquet as a sort of a very compressed file format, but consider that JSON is the best consumed format for ADX. You can use many kinds of connectors. For example, in my typical use case, I have Kafka clusters with rough data, and I have to ingest all the data in real time. So many records per second, okay, for every sensor, and put the data into a temporary database in order to analyze it. And so consider, for example, to use the certified connector for Kafka. When you consider ingestion phase, consider format and compression. So blobs and files can be compressed through two kinds of algorithms. So gzip or zip compression algorithm. And please indicate compression by appending the extension to the name of the blob or file. And consider the problem of declaring schema mapping. In some case is mandatory. For example, JSON or Avro mapping, and the JSON mapping, for example, must be pre-created on the table and referenced from the ingest command pattern. So first, declare table. Second, declare mapping. Third, reference the mapping name when you load the JSON, for example. In other cases, the mapping is optional, okay? You can have it in order to declare better, which is the format of the data, for example, integer or float or double and so on, or datetime, for example. My ingestion best experience. This is a typical use case. So you can have telemetry dumps that comes from the edge world and are synchronized to the cloud world. And you can have alerts that comes from the edge. These are parallel way. And using event read, you can ingest all the data using event tab as a sort of support object. And from the other side, you can have a sort of event manager that puts the data into a sort of writing point, another event hub with few elements. Probably these elements are enriched by the function, and after that they are linked to another table. These two ways makes a sort of joined situation between telemetry and alerts. After the ingestion phase, you can deal with the atomic transformation of data in order to append rough data to a target table whenever new data is inserted into the source table. This is based on a transformation query that runs on the data inserted into the source table. So the query can invoke stored functions. Imagine that a function is a sort of transformation or enrichment or projection. But the query that is part of the update policy can't include cross-database or cross-cluster queries. Okay, so if you have to deal with from free text to column transformation, or you can have cascading updates. Okay, cascading updates are allowed. So the table A with rough data trigger a sort of new insert of other data into table B that is linked to another and another and another in order to have a sort of automatic refinement of the data. And for example, a row table can have a time to live that is different from the refined table. This, for example, is a typical set of operations in order to use update policy. So you have a function, my update function, okay? So that brings data from the rough table. You can have where, summarizations, join with other internal tables, and projections. And you can have the target table, okay? So set or append target table with the execution of the function. And after that, after the two instructions, you can you can deal with the update policy, so the alter table policy update. So in order to summarize the update policy concept, use this pattern. Okay, so source table, update policy, many update policies with many target tables. Remember that first table is never wide, but the target table can be wide tables. So the first table schema probably is a KV, timestamp, and metadata schema. Okay, so timestamp, device ID, and value. But the second table schema can be wide table or telemetry oriented, so with the offsets in the columns, or machine learning oriented, so the classical TS and params table. Okay, let's go on with the query data. First of all, if you are a SQL user, use this technique to approach KQL, that is the Kusto query language. You can find it in log analytics, application insights, many services on Azure, and all these services are based on ADX too. Okay, so if you want to perform and learn, if you want to perform Kusto queries rapidly and you want to learn KQL, simply put this configuration. So dash explain, write your classical SQL query, and the result of execution will be the equivalent query translated with the KQL. These are some examples, okay? So use the pipe in order to compose queries, and use extend in order to make new fields in the query, summarize in order to define clusterization of data, and you can use toScalar in order to preprocess data. Okay, the best one is to save queries and use them as a sort of composable object that is the function. Okay. Other things, use of LET in order to save parameters, okay, or tabular expression in general, okay, or bin expression in order to summarize data. Let me jump into the bin operator. So you can round the values down to an integer that is multiple of a size. For example, take a series and make a bin expression in order to summarize it using days or using hours. Okay. For example, this, okay, count the number of hits by a sort of grouping, okay, duration with 1 second. Another important operator is make series, okay. ADX is a time series database, so you have to deal with series, and you can re-step all your telemetry data using a stepper, okay? For example, in this query, make series on, this is the field, the timestamp field, from 2 with the step. Talk about ADX functions, okay, are reusable queries or are query parts. You can compose them, okay, as a sort of castle made by progressively enhanced queries, okay, that are stored into functions. And is very useful if you have a big problem to solve and you want to write down queries step by step. Materialized views are another important object, okay? So think about that you have a source table and you want to view this table with the minimum, maximum values, and so on. So you want to have a summarized table, and you can use materialization in order to build up a newer table with summarized data. Periodically, okay, there is an update between the source and the target table. And that's it. You have your summarized data automatically. Caching is important too, because you can use different level of storage, okay, as we said before. And you can have a lower resource consumption in terms of IOPS within the disks. And because, for example, you want to have a result that is not so deep in the time, okay? And so the cache policy can define the max age of the query results. Partitioning. Oh, partitioning is a very, very technical argument. Imagine that you can have many partitions in the time, and the partition that are made today are not the same that ADX maintains during the time. So during the time, all the partitions are redistributed, and you must decide which is the partition key. For example, date time column, or string column, for example, machine ID, or date time, so month, for example. And ADX, repartition of the data based on the creation pattern, okay, so the ingestion time. So, sorry, the creation time, not the ingestion time, between all the partitions. These are defined as extents, okay? Okay, let's go on with the ADX view data. ADX offers a beautiful way to visualize data without having the problem to learn other business intelligence or related to business intelligence software. So if you are not an expert about Power BI, you can use directly ADX to visualize data, to make dashboards, to make a dashboard with visuals, with color changes and so on, based on telemetry. Okay, this is only an example, but you can have a sort of widget manager. Okay, click on the 3 points and change the query that is inside this widget. So it is very useful to compose HTML based interfaces with directly injected KQL queries inside every tile. My personal approach is to bring the data and follow a step-by-step function editing. So a first level of aggregation, a second level that uses not the rough data, but the first function. And then you can have multiple matryoshka, okay, multiple level of data masking and so on. When you find your data, so function 3, you can define KPIs, so projections in the third function, using the third function as the source. After that, you can import the queries with the KPIs definition, and you can use embeddable filters in your ADX UI. If you deal with the telemetry, probably you know Grafana. And so Grafana is a very, very special tool in order to retrieve information and in order to build up complicated dashboards. I want to inform you that ADX is present on the plugin store of Grafana, and you can use it, okay? If you use Grafana 7, you can use the plugin, and so you can deal with the dashboards, parameters, and so on, using embedded KQL queries also. Okay, let me talk about orchestration. Orchestration is a particular condition in which you can have more results derived from ADX pushed into other services. For example, you can push data to Power BI datasets, or you can have conditional queries in order to make data checks and send notification, or you can run queries and send emails with dashboards inside. For example, I can set trigger. So every hour I connect to a particular cluster, I make a particular query about my production, okay? And I configure an email block with dynamic parameters, and the result is this. Simple, but very efficient if, for example, I am a production director in a plant. Okay, go on with the ADX integration. What do we mean with integration? So the capability to integrate, to export data from ADX to another tool. For example, we can export data within a query in the async way, obviously. So you can export data to storage or to SQL. But the best way to use this kind of export operation is to make it a sort of continuous export. For example, you can create an external table in order to use the exported data. Let me explain better. Imagine that you have a sort of declared retention with your customer. So, for example, you can have 1 year of retention, and during this year, you can query directly ADX tables, I mean. After that, you can have a sort of data lake that is full of out-of-time data that is exported out, out of the database with this command. And this is exported to external location, so to export it to a storage account. But this storage account is queryable because is linked to ADX using an external table. So you can define a destination that is a source also. My best experience about ADX storage and ADX exports. This is the schema. Let me explain. From the database, I can have many logic apps that in the scheduled way trigger some query and export to an event tab some artificial alert. The alert is ingested in the ADX also in the alert table, okay? And after that, I've configured continuous export to SQL in order to have aggregated data. And I have linked to a storage account with the oldest data. And in this way, I can have long-term queries that are executed using ADX, but are executed on the storage. After that, you can have other things, for example, analysis services or classical databases. But from the ADX point of view, this is the best usage that you can have. So this is my final ADX recipe. Excluding triggers and alerts, in my opinion, you can use ADX in this way. So blob storage, batch ingestion, row tables, update policy, refined tables. From refined tables, you can have many ways to export or import data. For example, continuous export data into data lake and use this data as external table. Or you can have materialized views in order to fill up a SQL data warehouse. The SQL data warehouse can be seen as external table. Okay? And you can have triggered dynamic check queries. in order to refine data and materialize insights inside tables. Argument is regarding management. What do we mean with data encryption in ADX? First of all, is encryption at rest. And the key in order to encrypt the data is a Microsoft managed key, but you can enable your managed keys, okay? You can have key rotations, so you can disable and revoke access, and you can have soft delete, and you can have purge protection, okay? You can use key vault in order to do that. In order to clarify extents, policy, and partitions, Kusto is, or ADX, okay, Kusto is the code name, is built to support tables with a huge number of records. And to handle such large table, each table's data is divided into smaller tables that are called data shards or extents, okay? So the two terms are synonymous. And individual extents are kept smaller than a single node's capacity, obviously, and the extents are spread over the cluster nodes, achieving a scale-out methodology. Imagine that an extent is like a mini table, okay? It contains data and metadata and informations such as the creation date and optional tags that are associated with the data. You can deal with the tags, okay, even if extents are immutable. Every extent can never be modified, but it may only be queried, reassigned to a different node, or dropped out of the table. Extends all the collection of records that are physically arranged in columns. This technique is called, obviously, a columnar store, okay? And imagine that you can, when I say that you have a different storage level, I mean that you can have the columnar store and the row store. The row store is related to the cache, the initial period, and the columnar store is related to the long-term storage. To maintain query efficiency, sorry, smaller extents are merged into larger extents, and the merge is done automatically by a background process, or can be configured using merge policy and sharding policy. Policies are the most important concept to be learned when you deal with the ADX. When data partition policy is defined on a table, okay, extents go through another background process after they are created. So it is a post-ingestion process. And this process re-ingests the data from the source extents and create homogeneous extents, okay, in which the values of the column, that is the table's partition key, all belong to the same partition. If the policy includes an hash partition key, all homogeneous extents that belong to the same partition will be assigned to the same data node in the cluster. This is very, very important. Retention policy. You can specify which location must be used, okay? So you can say, I want to use the row store, so the hot cache, or the columnar store. And imagine that, remember that cache policy is very granular, and you can have two kind of cache policy, the hot data cache and cold data cache. But cache policy is independent from retention policy. You can have soft delete period. Remember that the default is set to 100 years, okay? And you can set the recoverability of the data. All the data is recoverable for 14 days after deletion. The last information is about that purge. And the data purge can be enabled only by opening a ticket. Because when you say this, the purge table, you have to specify with no regrets equal true. Okay? Is final and irreversible. Enable virtual networks, and so you can connect your plant, for example, to using your on-premises network to Azure Data Explorer subnet, and you can secure your data connections. For example, so you can secure Event Hub or Event Grid with service endpoints. So when you enable the VNet, you can have two independent IPs. The private IP, so in order to access the cluster inside the VNet, and the public IP, so for managing or monitoring, okay, from outside the VNet. Remember that you can have row-level security. So it is a total secure database, but using another service, not very well-known service, that is Azure Data Share, you can create a sort of symbolic link between two ADX clusters. So you can use a sort of read-only cluster, secondary cluster, that is the follower. And so you can use the computation, but not only its own Azure Blob Storage, but the blob storage that is linked. Okay, so you can have a sort of read and write ingestion query database that is the leader, and you can have other followers in order to query the leader data. Final thoughts. For me, ADX, this is the best database I never seen in my life. And in order to be clear, my best experience is regarding IoT. And I have anonymized this graph, but I would like to say that ADX can bring all the power of Azure in only one instrument. And using in my market landscape, ADX can be the difference for applications in general. And in my experience, I've used it using network separation, so site-to-site, VPN, private endpoints in order to protect all the first-level services, so IoT Hub and storage account. After that, separated from the UI, okay, that is on the right in the schema, there is the most important node, that is ADX, has got around him other services in order to bring information from storage, flow the information using several event hubs, and store all the information into other storage forms. Many thanks to local sponsors who collaborates with Microsoft. Thank you for your time. I hope that this session is interesting for you, and have a good Global Azure 2021. Bye-bye.